You have two charged particles contained separately, each with a positively charged spring as shown in the diagram. Positive charge is slowly added to one of the charged particles as an equal amount of negative charge is added to the other. How does the elastic energy change for the spring? We have four options. A, the elastic potential energy of both springs will increase equally. B, the elastic potential energy of both springs will decrease equally. C, the elastic potential energy of the spring in setup A will decrease and the elastic potential energy of the spring in setup B will increase. Or D, the elastic potential energy of the spring in setup A will increase and the elastic potential energy of the spring in setup B will decrease. The answer is A. When the negatively charged particle nears the positively charged spring, the spring will compress, gaining elastic energy. Stretching and compressing elastic objects generate elastic potential energy. When the positively charged particle nears the positively charged spring, the two repel, stretching the spring, generating energy. We know that opposites attract and same as repel. As previously stated, springs make energy, and when pulled on, as compressed, in setup A, there are two positives. In setup B, there is a positive and a negative. C, D, and B. These are wrong due to the fact that energy is made in both of the setups because, as previously stated, springs generate energy when compressed and stretched, as we see examples in the diagram. Therefore, it is false. The elastic potential energy of the spring can be increased by either stretching or compressing the spring. Adding positive charge to particle A increases the repulsive force between the particle and the spring, compressing spring more and increasing the elastic potential energy of it. Adding negative charge to particle B increases the attractive force between the particle and the spring, stretching it more and increasing the elastic potential energy of the spring. Since the strength of the force between the charged particles and the spheres are equal, the change in elastic potential energy in the springs is also equal. Elastic potential energy comes from how much an object has been stretched or compressed and how difficult it is to stretch or compress. Examples include rubber bands, strings, and elastic in clothing. As stated before, a positive string and positive particles repel, which in this case is stretching the spring, and a positive spring and negative particle attract and compress. So, how does the elastic potential energy increase on each spring? The elastic potential energy increases equally on each because the elastic potential energy increases when compressed and stretched, and the magnets are making the springs do just that.